we go over corrosion. Now, corrosion is defined as the spontaneous oxidation of metal. And we know that oxidation is the loss of electrons. So when a metal loses electrons to become a metal ion, such is called oxidation, and by that a metal is going to deteriorate, is going to get used up, is going to become much smaller until it vanishes if possible. And so say you have got a metal A. When it becomes a metal A, 2 plus 2 electrons. So this is a metal. Now it has become an ion by losing 2 electrons. What it has done is gotten oxidized. We know that oxidation is the loss of electrons. And so this is what causes corrosion. Now when we are referring to iron, the corrosion of iron is called rusting. Well, the word rusting is only talking about iron. Otherwise, when you are referring to other metals, it's just called corrosion. Now, corrosion happens in the presence of water and air. So without these two conditions, it's very difficult for you to have corrosion. It's very difficult for a metal to corrode. This mostly happens because when we are referring again to air, we are talking about oxygen. When oxygen interacts with a metal and then water, because oxygen has got a reduction potential which is more positive than most of the metals, metals tend to get oxidized, and because of that they become oxidized. Well, most of the metals which are used for construction, you are going to see that they've got a positive cell potential. Okay, they have a positive cell potential, except an example that we can, maybe an exception is God. Okay, but most of the metals which are used for construction have got a positive cell potential, such that if we reverse the reaction, because the cell potentials which are given are always given in terms of standard reduction potential. In other words, it's given as A2 plus 2 electrons going into A. This is called reduction because it's a gain of electrons. So the potentials which are given are reduction potentials, and most metals have got a positive reduction potential, such that when we reverse the reaction so that it becomes now A, for it to undergo oxidation, it now becomes A going into A2 plus 2 electrons. Now the cell potential becomes negative. So this value which is negative is now going to be added to the cell potential for oxygen. So when oxygen reacts with water and electrons, this is 2 water molecules plus 4 electrons to produce 4 hydroxide. The cell potential for this process is positive 0.4. And so this value for oxygen, if we add it to the value of the reaction that we've reversed, if it gives us a positive value, then that means that metal can be oxidized just spontaneously, just happens by itself. Okay, so let's consider an example. We see how oxidation happens. Well, before even looking at such an example, I want to talk about is we need to know that most of the metals which are, of course we are saying most of the metals which are used for construction can be easily oxidized, but in actual life they don't get oxidized. Why? Because just air itself provides a coating. The atmosphere contains oxygen, and this oxygen coats metals. For example, aluminium on itself can be easily oxidized by air. Can be easily oxidized when it reacts with oxygen in the presence of water. But because aluminium doesn't exist like the way it is in nature, it exists as aluminium oxide, bauxite. So this oxygen coats it. So if you have got aluminium a metal like that, there is oxygen all around it, that layer which forms aluminium oxide, and that protects aluminium from rust, from corroding, not rusting. Rusting is only for iron. Now let's consider the cell potential for aluminium itself. So when aluminium 3 plus gains the 3 electrons to produce aluminium, the cell potential for this process is negative 1.7 volts. And then for oxygen reacting with 4 water molecules, not 4 but 2, I don't know why I'm using 4, 2 water molecules and 4 electrons to produce 4 hydroxide ions. The cell potential for this process is positive 0.40 volts. Now we can see when this reaction is to be spontaneous, we need to reverse one of these reactants. Okay, we need to reverse one of these reactions, I mean. So it is either we reverse this or reverse this, but whenever we are reversing a reaction, we always reverse the one which is more negative. And so this reaction is more negative, and so we are going to reverse it. And so that becomes aluminium going into aluminium 3 plus the 3 electrons, and that is going to be a spontaneous process. So this is going to be positive 1.7. When we add it to this, we can see that aluminium is decreasing, is coming from being aluminium metal into aluminium ion, and that is what is called corrosion. And it gets reduced like that until the metal disappears. But this doesn't happen. If this used to happen, this can easily happen such that even when it is raining, just the rain that comes, when it drops on a building that contains aluminium, the building will start to melt. But this doesn't happen because aluminium is coated by oxygen. And most of the metals are coated just like that. Same with iron. Iron is also coated with oxygen. It's just that this coating is not such great. What happens is the coating, if this is iron, this is a metal ion, and then you have got iron oxide which forms as a protective layer. So this clusters off is going to be dropping out. The iron oxide is not such strong as aluminium oxide. So because of that, when it drops, still iron goes into iron 2 plus 2 electrons in the presence of oxygen and water, and still iron goes into corrosion, and that is referred to as rusting when we are referring to iron. So this is what we need to get to understand on this one. Well, what really happens for this process of iron rusting to happen? Let's consider it much more. We see what happens. So if we have got, let's say this is an iron bar, a steel bar, let me use steel. Now steel is made up of iron with the biggest percentage. You have got manganese, you have got sulfur, you have got chromium and such. So steel is actually an alloy. It is made up of iron and other metals. And so what happens if you have got a drop of water, if water drops on this compound, I mean on this bar, the steel bar, there are some regions which are called anodic regions. Now an anodic region, because steel is made up of different substances, an anodic region is a region that can easily undergo oxidation. That is because there's different proportions of iron and these other elements in steel. So the proportion that easily undergoes oxidation is what is called an anodic region. And so on an anodic region, what we are going to see is it can easily undergo oxidation when you have got a drop of water, Okay, so let's say this is a water droplet. So this is what you are referring to as the anodic region. And why refer to it as the anodic region? Remember, when we are talking about a galvanic cell, the anode is where oxidation happens. The anode is where losing of electrons happens. So it is referred to as the anodic region because at this portion, iron is being converted into iron 2 plus 2 electrons. And so if we have got oxygen at this point, so that is going to be called the cathodic region. Why? Because at that point the oxygen, so let's say on the anodic region, what is happening is iron is losing 2 electrons to become iron 2 plus. And then on the cathodic region, the oxygen we can see there is going to react again with water because we have got a presence of water. There is a water droplet there. So there is moisture, in other words, on this portion. So because of that, the oxygen is going to react with water. And then those 2 electrons which have been released by the ion will be taken in by the oxygen there, and that will produce hydroxide ions. So this is what happens on the cathodic region. And so rusting has happened. Now there is a transfer of electrons and ions here. So electrons are going to be able to move in the same steel bar which you are able to see. And so just like when you are considering a galvanic cell, we've got these electrodes. And then we have also a salt bridge. Okay. So what is happening is electrons are going to be moving through this bar. So the bar is going to act as a wire where electrons are transferred when we are talking about a galvanic cell. And well, the iron 2 plus ions are going to flow through moisture because we have got moisture, the presence of oxygen and water. So when this oxygen which is here, we have got of course water there which provides us with moisture, in other words, let me say. So the moisture is going to act as a salt bridge, and remember, a salt bridge is used as a point of connection between the two solutions so that ions are able to flow from one compartment to the other. And so in this case, the moisture is what is acting as a salt bridge. And so this is a full circuit, a full galvanic cell, where this portion itself, the steel, is acting as a wire where electrons can flow, and then moisture is acting as the salt bridge where ions are able to flow. And so this is a process which happens when rusting is happening. Okay, so it only happens on the anodic regions. It's not everywhere. That is because when you're talking about steel, well, we mostly don't use iron by itself because it can undergo oxidation, and so you coat it to protect it from undergoing oxidation. Still, even if you coat it, there are some portions where you've got a lot of iron because steel has got different compositions. Some, of course, we know that steel is made up of iron, chromium, sulfur, phosphorus, and such atoms or elements. So the points where oxidation can easily occur, those are called anodic regions. And so oxidation doesn't just happen anywhere. Because of this, rusting doesn't just happen anywhere. It happens on what is called anodic regions. Now, having understood this, how do we just prevent corrosion? Because we don't want to see this. Because when we let this to continue happening, buildings will go on collapsing, and there'll be a lot of destruction of property. So for us to avoid or to prevent corrosion from happening, in this case, let's talk about iron. For us to prevent rusting, because rusting is a special kind of corrosion. For us to prevent rusting, what do? The first way of preventing corrosion or preventing rusting is called primary protection. Now, primary protection involves coating an element with something that is more easily oxidized. Okay, for example, you can plate or electroplate. You can plate, let's say, steel with chromium and tin. You can also do it, you can also plate steel with zinc. So this is a primary protection. It is by electroplating or simply plating, and also by painting. So if you paint a metal, at least the paint is going to prevent oxygen from reacting with that metal, hence it will not be oxidized and it will be protected. Now when we are talking about electroplating, is simply coating a metal with a metal that can be more easily oxidized than itself. For example, let's talk of iron and zinc. We are saying we can protect iron by coating it with zinc. So if we consider zinc, when zinc loses 2 electrons to become zinc 2+, the cell potential for this is negative 0.76 volts. And let's talk of now iron 2+. When iron loses electrons to become iron 2+, the cell potential for this process is negative 0.44 volts. Now if we can look at these two, a question is, which one is a stronger oxidizing agent? Oxidizing agent, okay, let me not say oxidizing. Which one is a stronger reducing agent? A reducing agent is an agent which reduces others while itself gets oxidized. In other words, which of these two can be easily oxidized? Now, to consider which one can be more oxidized or easily oxidized, you look at the cell potential. The one which is more negative can be easily swapped. Okay, so this one can be easily swapped such that the cell potential becomes positive as compared to this, because when these two are reacting, what is going to happen is the one which is more negative swaps the reaction so that it becomes positive, such that if we add these two values, we are going to get a positive value. And so zinc is a stronger reducing agent as compared to iron, because it can be easily oxidized. Okay, so because of this, if we coat iron with zinc, we are going to have iron. Let's say this is iron bar, and then we put zinc all around it. We coat it with zinc. So instead, when this reacts with oxygen in the presence of, okay, when it reacts with oxygen and water, instead of the iron being converted into iron 2+ and 2 electrons, first what is going to happen is first the zinc will have to be converted into zinc 2+. So in other words, zinc is going to corrode in place of iron while the iron remains itself. And so electroplating is really coating a metal with another metal that can be more easily oxidized. Now, a special case when we are talking about iron being coated with zinc, such is called galvanizing. Galvanizing is simply electroplating, but it is a special case of electroplating where you are using zinc. So not different at all. Well, this is one way of protecting metals from corrosion. That is by primary protection, and primary protection we use either electroplating or painting. The other way is alloying. If you don't want a metal to be easily destroyed, you make it an alloy, and an alloy is a mixture of metals. For example, instead of you just having iron to use for a building. Instead, you use steel. So steel is an alloy of iron. That is because steel is made up of iron, chromium, phosphorus, sulfur, and such. So alloying makes metals much stronger. So when they become much stronger, they will be difficult to easily oxidize, and such protects them. Now, another way of protecting metals is called cathodic protection. Now, what does cathodic protection involve? So when we are talking about cathodic protection, let's consider what happens. Well, let's say we have got, this is an iron pipe. So this is underground. This is an iron pipe. So we are going to attach, using a wire, we are going to attach another metal. So this is a metal that can be easily oxidized instead of iron. So we attach it. This is underground, so we want to protect. An example that we can use is, of course, this is an iron pipe. We can use magnesium. So if we consider the reduction potentials for these, magnesium can be converted into magnesium 2 plus. Let me write it somewhere here to have much space. Okay, magnesium can be converted into magnesium 2 plus 2 electrons, and the cell potential for this reaction is positive 2.37. Now iron itself, when iron is to be converted into iron 2 plus 2 electrons, the cell potential is positive 0.44 volts. So when you have got these two, well, when they are reacting with, remember, when we're talking of corrosion, it is supposed to be oxygen, of course, having to react with a compound or a metal. So the diagram I show, sorry for the disappearance, let me put it again. This is magnesium, that's the iron pipe. So the cell potentials we are talking about is magnesium going into magnesium 2 plus 2 electrons, and we are saying this is positive 2.37 volts, and then the iron itself going into iron 2 plus 2 electrons, the cell potential is 0.44 volts. So this is a wire that is connecting the iron and the magnesium. So what happens in cathodic protection is we are going to protect steel in pipes and also in tanks. Okay, maybe a tank or a pipe. We want to protect it so that it doesn't rust, because water is going to be passing here, and that is bad, because just when water is interacting with iron, of course, even in the ground, oxygen is present there, it is going to undergo rusting. So instead of us, this metal which you've put underground, when it starts rusting there, it will be very difficult for you to start putting another pipe down there. It might cost a lot of money. So you do what is called the cathodic protection. So what really happens in here? So an active metal such as magnesium, as we can see, magnesium is active. That is because its oxidation reaction has got a higher cell potential than the oxidation reaction for iron. So it is an active metal. So you use an active metal and then you connect it to the steel. So this is a steel pipe. Now, because magnesium is a beta reducing agent, as we can see, beta reducing agent means when we reverse, because the reduction potentials are given as magnesium 2 plus 2 electrons going into magnesium, and the value is negative 2.37, and then iron 2 plus 2 electrons going into iron the value is negative 0.44. These are in voltages. So a beta reducing agent is something that can be easily oxidized. And to know which one will be easily oxidized, we know oxidation is the loss of electrons. Which reaction of these are we able to swap first? So you look at the smaller the cell potential, the better it is for that one to be oxidized, I mean. So we swap this reaction. So it is very easy to swap this reaction, so because the value is very small for that one. So when you are comparing these two values, so because magnesium is a beta oxidizing agent, we are going to use it. I mean, beta reducing agent. A compound that undergoes oxidation is a reducing agent. Okay, we use it. And so electrons are going to be furnished by magnesium instead of iron. So instead of this iron losing electrons, as we can see on here, magnesium instead is going to lose electrons when there is an interaction with the air which is down there and also the water. So this is very important, and this protects the steel which is down from getting to rust. So cathodic protection is very important. This is what we use in tanks and also in pipes which are underground. So the iron is going to be kept from getting oxidized, and so it is protected from undergoing oxidation or rusting. So these are the ways of preventing corrosion, and this was about corrosion. What to understand more about it, you are sure to have even much deeper researches, and that is going to help you. If this was a better video for you and if it helped, you do good to subscribe. Enjoy your day.